All right, good morning. Welcome to Cup 2. So today we're going to talk about volumes of revolution. Okay, so you don't have to deal with the really hard ones, but we will talk about how to do this. So let me go ahead and tell you what we're doing. Okay, so the idea is that we're going to come up with a bunch of cylinders. Okay, so on a coordinate axis, if I had just a straight line, y equals 2, for example. Okay, this would be 2 above. What we're going to do is we're going to rotate this around the axis. Okay, and because in a regular problem this is going to be changing, okay, we're going to be dealing with adding up all of these little cylinders here. Okay, so volume of a cylinder, right, pi r squared h. So for this problem, r is going to be pretty constant because we just drew a line. Okay, so it's just going to be 2, r squared 2. And then the h is going to be a dx because we're just taking all of these little pieces here. Okay, we have a pi, and then we're going to have a whole bunch of those pieces. We're going to add them up. That's what we do with the integral here. Okay, so if we wanted to go from like 0 to 3, okay, so this would be 4 pi, right? 2 squared is 4 pi, dx from, right, 0 to 3. So what I would do is say 4 pi times integral of dx, just x. We're going to go from 0 to 3. So we're going to go from 4 pi times 3 minus 0. So 4 pi times 3 is equal to 12. And if you went and did an r equals 2, height is equal to 3, right? We get the same answer. So we get pi, 2 squared times 3. We'd end up with 4 times 3 pi, which is 12 pi. Okay, now what happens if the radius isn't constant? Okay, so what if I wanted to figure out something like that, right? This is called a frustum. This is like the size of like a gasoline coffee shop kind of thing, coffee cup. Okay, so what we're going to do is we're going to rotate this around. Okay, so what if I wanted to figure out from 0 to, again, we'll go from 0 to 3. Okay, so we're going to go integral from 0 to 3. We have a pi, we have an r squared. But in this case, it's not a constant thing. So what if we have this function of y is equal to 1/2 x, or y equals, how about 1/2 x plus 1? That's going to start above the axis here. So we're going to have 1/2 x plus 1. But since this is my radius, we're going to square that. And we're going to have our dx because we're going to sum up, that's the integral part, sum up all of these tiny little summations here, all these little cylinders. We're going to sum them up. That's what we're doing with the integral. So this is a more problematic kind of a problem because we have the squared here. You have to remember to deal with the squared. So this is pi, okay, from 0 to 3. And I've got to FOIL this out, right? If you don't know, if you can't do it in your head, that's fine. But we're going to FOIL this out. So it's going to be 1/2 x plus 1 times 1/2 x plus 1. So 1/2 times 1/2 is 1/4. So we have 1/4 x squared. We have 1/2 x times plus 1/2 x. So that's just going to be plus x. Okay. And then 1 times 1 is just going to be 1. So all I did to do this, to get this value here, I just said 1/2 x plus 1 times 1/2 x plus 1. Okay, my firsts, right, that's 1/4 x squared. My outers, that's going to be 1/2 x. My inners, that's going to be 1/2 x. And my lasts are going to be just 1. I just added those up. So 1/4 x squared plus 1/2 and 1/2 makes 1, so 1x plus 1. Okay, so that's my radius squared times the height is going to be dx. The height's always dx in this case. Okay, so again, we're going to go from 0 to 3, and this is going to be the volume of how much coffee that my coffee cup that looks like this thing holds. Okay. So this is not too bad of an integral. So this is just half, and we just integrate this. So this is going to be 1/4 x3 over 3 plus x squared over 2 plus x. Okay, and we're going from 0 to 3. So put this a little bit nicer. So we have pi, where 1/4 plus 1/3, that's 1/12. So 1/12 x cubed plus 1/2 x squared plus x. We're going from 0 to 3. If I plug in 0, we're just going to get zeros here. Okay, so we're just going to have pi, and then we have 1/12 times 3 cubed plus 1/2 times 3 squared plus 3 minus 0. Okay, and we just have to do this arithmetic, and then we should be set. Okay, so this is going to be pi 27/12 plus 9/2 plus 3. Okay, and that's all we're going to do with that. Go ahead and plug this in. So this is 27/12. No, I want divides. That's what I want. But come on. Divide 12. Okay, plus 9/2 plus 3. Okay, 9.75. I can go ahead and do this, make it into a fraction. So it's 39/4, so it's 39 pi over 4, and that is the volume of this frustrum here. Okay, and that's all we're doing with it. Okay, things to be careful about is making sure that you get your rules of exponents sorted out, because sometimes they're a little bit more complicated. Okay, so let's see if we could do a couple of different things. This is very much like the first one we just did. Okay, it's actually the example I just did was actually harder than this. Let's go ahead. Let's look at this one. Okay, so here we go. We have y equals 1 plus x. We're going to go from x is equal to 2 to x is equal to 12. Okay, one of the things I always like to do this, because in the engineering calculus, they always expect you to draw it first. So if I go, it's a very busy day today. Sorry about that. So if we say y, let's clear this. Okay, if we say y is equal to, what I want to do is I want to do square root of 1 plus x. Okay, so that should give me square root of 1 plus x, everything's in parentheses. And we go to our window, okay, because where are we going from? We're going from x equals 2. Let's start from 0 to 12. Let's go up to 15. Pick easy numbers. Okay, scaling 1, it's no big deal. From 1, we don't need up to 50, right? What is y going to be? So if we type in 12 here, 12 plus 1 is 13. We take the square root of 13. We'll go up to 4. Okay, 16 would be the whole thing. We can even go up to 5. Okay, and we'll just go ahead and call it that, and we'll just say graph. Okay, and that's what this guy looks like. Okay, actually, x could have been -1. That would have been all the way down. Let's go back to window. Let's go to -2 up to 15. It's a graph, because that way I'll start down from the 0 point. Okay, so here we go as our graph. Okay, and we're going to rotate it around here. Okay, so we're going to go from 1, 2 here up to 12. Call that 12. So here's the region. So if you think about like rotating this thing around the axis here, again, what we're going to be looking at is some kind of a wine cup or something. Okay, have that. We'll have this, and then let's put it. If I put it like instead of side to side, up and down. Okay, but it's going to look like some kind of a cup. All right, now figure out the volume here. So this is pi from 2 to 12 r squared. So that's going to be the square root of 1 plus x squared dx. Okay, so you can see like how these get to be a little bit, they could be a little bit easier, they could be a little bit harder. Okay, so we're going to end up with square to square root. So this is pi from 2 to 12. Okay, 1 plus x dx. All we did was square the square roots. Now we have to integrate. Okay, so this is going to be pi. This is going to be x plus x squared over 2 to the 12. Okay, so it's not too bad of an integral. So we have pi, and now we have the hard part. This is going to be like, 12 plus 12 squared over 2 minus 2 plus 2 squared over 2. Okay, so let's go ahead and have a look at this. So this is going to be 12 plus, what's 144 over 2? Okay, so 144 divided by 2. 12 squared is 144. Okay, 72 minus, and then 4 squared over 2 is also 2, so 2 plus 2. Don't forget the pi, that's almost everything that people do. Okay, 12 and 72, that's going to be what? 84 minus 4 times pi. So we get 80 pi, and that's our answer for that one. Okay. So exact which terms in terms of pi here, so that's fine. So times, I wonder if they'll do that. It did, look at this. Okay, we'll say check. Great, okay, moving on. All right. All right. Oh, we can do this one. This one looks fine. Okay. So what we're going to have here is 2 over the square root of x. Okay, and we are going to go from 4 to 7. Okay, so we have, let's go ahead and look at this. We have 2 over root x from x equals 4 to x equals 7, right? So what is this going to look like? All right, I know what 2 over root x looks like. It kind of looks like this thing. Okay, so I suspect it's going to look pretty close. Okay, so when x equals 4, right, 2 over, what is 2 over root 4? That's going to be 2 over 2, which is 1, so the y value is 1. And then we have 7, we have 2 over root 7. Okay, let's call it something else for now. Well, what's the square root of 7? It's like, well, 3-ish? No, it's not quite 3, it's like 2 point something. Okay, the square root of 9 would be 7. So let's just change this, just because we're trying to get an idea for the calculator. So this would be 2/3. So we're going to go from 1 to 2/3, which give or take. So when I go ahead and say, well, I'd like to graph this, we say y, that's clear. I'm going to say 2 divided by the square root of x, okay? And what's our window going to look like? We don't want negatives because it's not going to appear. We started from 4, so we can go ahead and make our minimum value. How about we go, well, it's not going to like 0. We'll go from 1, okay? And then we only have to go up to 7. Let's go up to 9, okay? Scaling for y, we'll leave that alone. Y minimum will go from 0. That's fine because 2/3 is close to that. And then y max. If I plug in a 1 here, we just get 2 over 1. So we'll just do a 2 here. Okay. These are not requirements. You will get better at managing your window the more you practice. And you want to definitely overestimate how much room you're going to need. And you know what? If you mess up, you can always come back to window and retry it. Okay, it's not the end of the world. So we'll go ahead and do that. Okay. So yeah, where do we start from? We started from 1. So we're going to be doing something like this. Okay. And what we're going to do is we're going to rotate this around this axis. Okay. So again, it's going to be like a cup, but it's going to look more like a, it's going to look more like a thing you would drink champagne out of, because it's going to have a little stem here. Maybe it's a thicker stem, so you think maybe it looks like more of a thing you would drink beer out of, but that's the kind of thing that we're going to be drawing. Okay. Again, the more of these you do, the easier it's going to be for you to see it. But this is not a requirement for your class. You don't have to draw it. I just like to, because there's a wider class of problems we get to rotate things around an axis, and does tend to help to draw them so you know what you're looking for. Okay, so this is a pi. We're going from what? Where are we going from? We're going from 2 to 7. We're going from 4 to 7, aren't we? 4 to 7. Okay, that came out of the problem. Okay, and then we have 2 over the square root of x squared. Okay, you have to memorize that, the radius squared, times we're going to be adding up all of these tiny little disks. Okay, as a matter of fact, that's what it's called in the engineering classes, the disk method. Okay, so we're just adding up. Oh, no, it isn't. It's Washer method, sorry. It's Washer method. But then we're going to be, because they have some other functions that, like, there might be a thing here and a thing here. You're rotating this one around, but you have to take the fact that there's like a straw in the middle, and you have to subtract that out. Okay, and that's what they do. So taking our time, multiplying this out, right? We have from 4 to 7. 2 squared is going to be 4. Square root of x squared is just going to be x. And then we have our dx. This is what we have to integrate. You can integrate this, right? 1 over x dx, that is the natural log. So this is pi times 4 ln x. We're all going to be positive, so we don't need an absolute value there. We're going 4 to 7. Okay. And that's just how we're going to do this. So this is pi times 4. We have ln 7 minus ln 4. Just plugging those values in for our x. Okay. And there's a well-known logarithmic thing that lets us do this. We can have ln 4 pi times, and then here we're going to have ln of 7 over 4. This is the rule of logarithm, where you have natural log of a minus natural log of b. That's equal to natural log of a over b. Okay, it's important to remember your logarithmic rules here. Yeah, but that's, and then we have a pi. So that would be our answer for this thing. They wanted use exact, okay, use pi. So we're going to have 4 pi times ln of 7 over 4. I don't think they're really going to get mad at you if you have ln of 7 minus ln of 4. So we'll see. Check this guy out. And then where we are. Okay. So what I wanted to do was one more. And one previous to this. I just wanted to make sure that if you knew what to do for x equals -3 and positive 8. So again, what do we have here? We have y equals e to the x from x equals -3 to, that's going to be a big number, 8. Okay, so we're going to be doing something like this. Okay, so this thing, as I rotate it around, okay, it's going to look kind of like a funnel. All right, it's going to be a huge head here, huge top, and a tiny little neck here. That's what it's going to look like. All right. Again, not required. Just something I like to do because in other problems it is required. Okay, you guys do not have to do this. Okay, so here we go. Again, let's graph it. Let's go back to our y equals. Let's clear that, and we're just going to have e to the x. Okay, now we go to the window. Okay, x min. Let's go to -4. This negative. Okay, and we're going all the way up to 8. So let's go a little bit bigger. We'll say 9. That's fine. Scaling will be 1. That's okay. 9. Okay, minimum 0. That'll work. Now maximum. What is e to the 9th? Okay, so if we go ahead and we take a look at e to the 9th. Oh, sorry. Actually, that'll work. It's e to the 9th. Okay, so that's the biggest number I'm going to have there. Let's go with +1. Okay, and then we'll go ahead and see if we can't graph this. Thinking. So yeah, here's my e to the -3. It's almost not visible, and here's my e to the 9th. So if I go ahead and look at what is e to the 9th, it's going to be a big number. Okay, 8,000. And what is e to the negative 3? It's less than 1. Right? It's going to be like 1. It's going to be 0.1, 0.01 or something like that. So we have negative 3. It's like 1 over 27, 1 over 30, something like that. 0.05. So yeah, we're going from 0.05 to 8,000. Okay, that's a big space. Okay, so this gets really, really narrow. This gets really, really wide at the edge here. But pi integral from negative 3 to 8. Is it 8 this time? It's 8. Okay, and then this one is going to be e to the x squared dx. Right, so this is going to be negative 3 to 8. This is e to the negative 2 or e to the positive 2x, right? Because rules of exponents, we multiply dx, put a pi out here. Okay, so we go ahead and integrate this. So this is going to be e to the 2x times 1/2. Okay, if I take the derivative, I get back e to the 2x. That's what I'm kind of doing. Okay, so that's this thing integrated. We're going to integrate from negative 3 to positive, what, 8? Positive 8. Okay, it is about the x-axis. All right, so pi. Okay, so this is our dx here. So we have pi over 2. Okay, we have e to the 8 times 2, so 16 minus e to the 2 times negative 3 times negative 6. Okay, I don't want to put that in the calculator. We'll see if because they want it exact, so we'll see if we have a chance at this. Okay, so this is pi over 2. So this is pi over 2 times the quantity. We have e to the 16 minus e to the negative 6. Okay, and we're hoping for the best on that one. And that's how we do that. Okay, so don't be intimidated by this. There are going to be some wacky numbers sometimes. Be careful, because if we go ahead and do like a x to the 1/2 e to the x, and I square it, that's going to be x, because the square root, e to the x. That's going to be integration by parts. I don't know why your book does not put integration by parts in here, but they should, and I do. So be careful, practice this one. I think this is a worksheet one. So go ahead and practice, just in case there's integration by parts on it. Okay, so chances are I could also do something like an x times the square root of ln x squared. So this is just going to be x ln x, which again is an integration by parts problem. All right, so be careful about that, and good luck with the homework, and I will see you in the next video. Thank you.